Hello everyone, so today we're going to be talking about minerals and more specifically how ionic bonds are formed and what determines the strength of ionic bonds. By the end of this video, I hope that you will be able to understand what minerals are, how ionic bonds are formed, what they are, and what determines the strength of ionic bonds, also the breakdown and equation of how to find the potential energy needed to break the bonds or to pull the particles apart. So let's get started. We're just going to do a really quick recap on what minerals are. So minerals are naturally occurring inorganic solid that are the building blocks for rocks. It's very important to look into minerals because they tell us how Earth has formed and changed over time. So these are some examples, and two of them, quartz and halite, we will be talking about today. But these are all very common minerals on Earth. So how are ionic bonds formed? So this goes back to PSC 102. This will be a good refresher for the upcoming exam. So ionic bonds form when electrons are transferred, creating opposite charge ions that stick together due to electrostatic attraction. So it'll be between one metal and one nonmetal. As you can see, there is sodium and chloride, and one's positive, one's negative, so they will attract. So I will be showing you a very quick demonstration of how to figure out ionic bonds. To give a quick visual, we're going to do sodium and chloride. So here we know sodium has one valence electron and chloride has 7. They want to fill up their shells, and so what's going to happen is that sodium, which is a metal, is going to lose its electron and give it to chloride. Then chloride will have a full shell, and sodium will also have a full shell. So then the sodium will be a positive charge and the chloride will be a negative charge. And this is because the sodium lost an electron and the chloride gained an electron. Perfect. So now we know that ionic bonds make up 90% of all minerals found on Earth's crust, which is crazy. But the basic process of ionic bonds are the same, but it's just a little bit more complex when it comes to minerals. So let's take a look at some salt, which we know is sodium chloride. We see that there is a negative chloride and positive sodium. Well, since we know that positives attract, this chloride is going to attract other sodiums, and sodium is going to attract the chloride. So this will make it into a 3D geometric shape because it's just going to be kind of filling in those spots. As we can see here, this is only touching the sodiums, and these are only touching the chlorides. Explanation on how it forms the way it does. So just know that because they attract and they will continue to attract, that means they're going to slowly start filling up as a geometric shape, kind of like what we did with, actually exactly like what we did with the grapefruit. So just keep that as a reminder. Perfect. So what determines the strength? So the strength of ionic bonds depend on how much potential energy is needed to pull the particles apart. This depends on the charge of the ions and distance. So this is our main equation. So to kind of break it down a bit, the Q's are the electric charges, and the R is the distance, and then the U is the electric potential energy that we want to find. So here are the two that we are going to compare, which is halite and quartz. So with the Q's at the top, you're going to, which is the charges. So we know that sodium has a charge of 1 and chloride has a negative charge of 1. So we're going to multiply those and divide it by the distance of the two, and that will be negative 0.36. And then we're going to do the same exact thing for quartz. So the charge for silicone is going to be 4, and the charge for oxygen is going to be negative 2. And then we're going to multiply that and divide it by the distance, which will be 4.68. So now that we have the two, we can see that quartz has a much higher amount of strength. This would mean that it would take much more energy to break it. So that's kind of how we can compare the two and figure out which ionic bond is stronger. Thank you so much for listening. If you have any questions, please feel free to ask me.